Good evening, everybody. My name is Mel Callan. I'm a member of the Penfield Green Initiative, and tell you a little bit about us, and then I'm going to introduce the members of our steering committee. Our vision is, as Penfield residents, and we have a vision of wanting to promote positive environmental action and provide a forum for the general public to be involved in supporting a green Penfield. And we've been around since about 2007. We've put on various programs for residents of Penfield of different topics. And so tonight, we are having one that we've called A Conversation About Hydro-Fracking. We appreciate and thank all of you for coming tonight. Now, for the other members of the Penfield Green Initiative, if you'll stand so folks can see you, Deb Murator, Robin Miller, Peter Maurer is in the audience, I know. Peter and Kate, I know there's Kate Walker here, McArdle. Georgina Terry could not make it tonight. She had to be out of town, and we got Sue DeRosa. I also want to thank PCTV, Penfield Cable Television, for all of their assistance tonight. They've been a wonderful support for us, and this is going to be taped. It's not live, but it's going to be taped and therefore shown on cable television at various times in the near future. I also like to thank the town of Penfield for letting us use this auditorium tonight. Very appreciative of that. Tonight's speakers are, we were fortunate to have two gentlemen who, in different ways, have become experts and speakers on this topic of hydrofracking. First, we have Josh Goldowitz, who is a professor and undergraduate chairman of RIT's Environmental Sustainability, Health, and Safety Program, where he teaches environmental geology, hydrology, and environmental sampling courses. He has more than 20 years of experience designing and implementing cleanup strategies for contaminated groundwater aquifers and surface water bodies. Josh will be our first speaker. Then we have Jordon Kleiman, who's an associate professor of history at SUNY Geneseo, where his teaching focuses on the intersection of technology and the environment in the modern U.S. His current research examines the relationship between environmental justice and the alternative technology movement. He is also co-founder of the Rush Citizens Concerned About Hydrofracking. And finally, we have a wonderful volunteer who is Kurt Miller. He's a administrative law judge who is going to be our moderator for this evening. And he's going to go over the agenda and just some of the ground rules to participate in this evening's discussion. And I think that's it. At the end of the 2 hours, towards the end, we'll have a little wrap-up. And hope you enjoyed tonight's event. And thank you all for coming.
Each one of our speakers will be given 40 minutes each to give you a presentation of their view of the background and the facts behind this particular issue. When they are done speaking, there will be 30 minutes allowed to ask questions of the speakers. Now, we're going to limit each question to 1 minute. That means you'll have a minute to ask the question. These gentlemen can take as long as they'd like within reason in answering the question. Okay, we're going to ask everyone to limit your questions to one per person. If we have time and you have additional questions, we'll be happy to let you come back up. But we're going to try to give everyone an opportunity to ask a question before we do that. Additionally, I understand that this is a very emotional issue for some people, but we're going to ask that you don't try to limit yourself as far as giving your opinion is concerned. We would like to have questions concerning facts and data behind this issue rather than actual opinions in this matter. And we're going to ask that everybody be respectful of everyone else, to the speakers and to your fellow audience members. And let's see if we can get the most out of this. And I appreciate your cooperation before we get started. Thank you. And first we have Josh Goldowitz.
Well, thank you so much, Mel, and the other members of the committee. Thank you for that wonderful introduction. As Mel mentioned, I teach geology and hydrology to undergrads at RIT, so I'm ordinarily talking to 18 to 22-year-olds, and it's ordinarily a lot earlier in the day, so I'm not really used to talking to a group like this. And by a group like this, I mean people who are actually, you know, awake. So I'll do my best. Let me see. Make sure this is working. Okay, so my talk, I'm calling it Hydro-Fracking 101. What I'm going to cover is kind of why are we here? Why are we talking about hydrofracking? What's the basic idea? Where is the Marcellus shale? What is shale? To make sure that you have that information to help you make a good decision on this issue. I'll give you the basics of what horizontal drilling and hydrofracking actually means. What's the technology, so you'll know all the steps. We'll talk about some of the environmental benefits and dangers. And yes, there actually are environmental benefits to hydrofracking. My last minute or two will be about what I think is a moral dilemma. I think this is really more of a moral question than a technical question. You could see if you agree with me when we're done. So, before we talk about Marcellus, let's do some fossil fuels. We have to do what I call fossil fuels in 4 minutes. So, first of all, are they fossils? Are the fossil fuels fossils? Yeah, well, I guess they are. You know, they're from pre-existing life millions and millions of years ago, and they still exist now, and we could take a look at them. So in a way, they're fossils. How did the fossil fuels form? What I want to do is I'm going to talk about how oil forms real briefly, because all the fossil fuels form in a relatively similar way. So let's go through oil real briefly. So here's what has to happen for a crude oil deposit to form. Crude oil forms in deposits from the marine environment, so only in the ocean. You have to have a great deal of dead material, biological material, fall to the bottom of the ocean relatively quickly, and it has to be covered by other sediment. If it's not covered by other sediment very quickly, then organisms would eat it or microorganisms would eat it. Then it needs to be covered by thousands of feet of sediment so that that layer of rock or sediment that contains all that organic matter is buried someplace between 7,000 feet and 15,000 feet below the sea floor. Okay? The material turns into a liquid, turns into a crude oil, then it will rise up and needs to get capped or captured by another rock. So those are a bunch of steps. Mother Nature is a relatively harsh grader, you might say. If every one of those steps doesn't happen in exactly the right order, the amount of crude oil you have is 0. Okay? So that's something about how fossil fuels form. We have here a picture of some crude oil in a container. Couldn't really take a picture of natural gas, so there's some natural gas burning. This is a lump of coal I have in my office. See how much fun you get to be when you're a geology professor. And this is tar sands. These first 3 fuels, oil, natural gas, and coal, are called the conventional fossil fuels. Tar sand, which is mined currently in Western Canada, is an unconventional fossil fuel. It's relatively new. So that's kind of the universe of fuels. What do we use our fossil fuels for? So any suggestions from the audience? What do we use all these fossil fuels for? Heat, make plastic, transportation, heat engines, make electricity, right? So we use all these fossil fuels for these various uses. And something I think that's really important to understand is all these fossil fuels are interchangeable. We could use any fossil fuel for any one of those uses, okay? It's a little hard to imagine shuffling coal into your car and driving on coal, but we do have the technology to turn coal into a liquid fuel. That's what Germany ran on in World War II, since they have no crude oil. And all of these fossil fuels are stored solar energy. What's the problem? Why are we even talking about this? Here's the problem. This graph goes from it's a time on the x-axis from 1935 up to 2010. And on the y-axis, it's millions of barrels per day. of production of oil in the U.S., right? In about 1957 or so, a geologist working for Shell Oil, a guy named M.K. Hubert, said, we are going to peak in our oil production in the U.S. around 1973. He made that prediction in the mid-50s, but he was wrong, because we peaked in 72. So he's pretty much right. And if you use the same math that he used, his same methods, he determined that the world was going to peak around now. So peak oil production, making less and less each year in subsequent years. So this is the same graph, basically. These bars show when the big oil fields were discovered. So here is Kuwait, here's Saudi Arabia in 1950 or so, here's Siberia in the 70s, and here is production. Notice as time goes on, the big oil finds are smaller and smaller. We've already found the really big ones. Environmental consequences. There are environmental consequences to every fossil fuel. Okay, so this is a picture of some mountaintop coal mining in West Virginia. Mountaintop coal mining is a pretty interesting technology. So here, everybody in the audience do this. Okay, so there's a mountaintop. If you could picture at a level about like that is a layer of coal. So there's a layer of coal, there's the mountaintop, there's a layer of coal. What do? You take the top of the mountain, blast it off, right? There's your coal. What do you do with all that rock that you blast off? You push it off into the valley. Okay, that's what they do in West Virginia. So that destroys the biome or the ecology of the mountaintop. It really destroys the ecology of the stream. Environmental consequences. There's a burning oil rig in the Gulf of Mexico. You should be familiar with that. This one's the unconventional. This is tar sands in Western Canada. This is sand, and it's filled with a tar-like material that is so thick it won't flow. So what they do is they literally dig up vast swaths of land, take that tar sand and heat it, and when you heat it, the tar will drip out, and they could use that to make crude oil. So the big hullabaloo about the pipeline coming from Canada down, that's what it's for. It's oil from that tar sand. How do they heat that tar sand? You'll never believe how they heat that tar sand to make the crude oil type stuff drip out. The way they heat it is with natural gas. So huge environmental consequences to this stuff. That's probably the worst. Environmental consequences when we burn fossil fuel, greenhouse effect. Basic idea, light comes in from the sun, warms the earth, a certain amount bounces off, and our greenhouse gases, CO2 and methane, keep some of that heat from radiating out into space. That's a good thing. The greenhouse effect is what keeps the earth at the temperature it should be. Nothing controversy about the greenhouse effect. But when we burn fossil fuels, we put more greenhouse gases into the atmosphere, and then you get more greenhouse effect, and the atmosphere warms up. So that's global warming. That, by the way, if you ask actual scientists who know what they're doing, is also not controversial. Okay? If anybody thinks that's controversial, because there are some scientists that say, oh, global warming isn't really happening, recall, I don't actually recall this, but I've read about it, and some of you may recall that in the 1950s, there were some doctors who said smoking was good for you. Right? Greenhouse effect, global warming, not controversial. Okay? Natural gas, let's take a look at what we're talking about. Put some equations up. This represents just an organic molecule, any kind of organic material. If this burns, you produce CO2 and water, if it burns completely. So that's what happens in a Chevy Volt. If you have that material and it decays without any oxygen, it produces methane. Okay? And methane is the natural gas we're talking about. So I've been talking for a little while and haven't even said the word Marcellus shale yet. Right? So there we go. So this talk is about Marcellus shale. So let's talk a little bit about what's in a name, how did it form, things like that. This is a picture that I took of the Marcellus shale. Interestingly enough, you can go to Leroy and go to Owatka Creek in Leroy, and the stream bed is made up of Marcellus shale. So you can hack some out of the rock. If you like, I brought some pieces you can pass around. So here's some Marcellus shale you can pass around. You'll notice it's very black. There are a few slightly jagged edges on this, so be careful while you pass that around.
Did you frack this?
I fracked it with a nice size rock hammer. So what's in the name? Marcellus shale, first of all. We have rock layers in New York, flat-lying sedimentary rock layers, but not just our rock layers in New York. Rock anywhere in the world is given a two-word name. The first word, where does it come from? Or where is it found at the surface? So does anybody know where Marcellus is?
Syracuse.
Near Syracuse. So there's a location in Marcellus, western, where the Marcellus shale, this rock layer, comes up to the Earth's surface. Comes right to the surface. And that's the first place geologists sampled it and described it. So that's how it gets that place name. Second part of the name is what type of rock is it? And this is a shale. Shale is made up of extremely small bits of material. So if you had sand, a layer of sand, and it got compressed under thousands of feet and became a rock, what kind of rock would it be? Okay, this is a smart audience, right? But if instead of sand you had clay particles that are more than 1,000 times smaller than sand particles, compress them, they become shale. So when and how did it form? We had this area, all of New York, Ohio, Pennsylvania. We were underneath an ocean. This is roughly 400 million years ago, nearly 400 million years ago. We were below an ocean, lots of sediment built up. Over those millions of years, it was compressed and became rock. Some of its properties. So shale, you can see some of the properties as it goes around. This is Marcellus shale. This is a black shale. The color is very dark. Why is it dark? Because it's got lots of organic material in it. Okay? So that's what decays and becomes natural gas. You can see in the picture, this is true at the surface, it's also true below ground. There are fractures in it. And there are a lot of kind of parallel fractures, or at right angles. Some are parallel, some are at right angles. This distance from here to here is, well, let me do one more higher up so you can see. This is about a foot from here to here. That gives you an idea of the scale. So it's naturally fractured. The pores, the spaces, are extremely small. So even though it's filled with natural gas, the natural gas cannot flow. Let's look at where it is in New York. So this is a map from New York State Geological Survey. Each color is a different rock type. The dark green here is a group of rocks that contains the Marcellus shale. So all along here, that's where it comes to the surface. So this is a map of what rocks you would find at the surface if you remove the soil and look below. Okay? Here's another picture of the same thing. This is a New York State stratigraphic section. So what that means is this is a list of all the different sedimentary rocks you would find in New York State stacked from top to bottom. This is kind of the list. And you'll notice if you could see the, I don't know whether you could see the names from where you're sitting, but remember two-word names. First word is where it's from. So you'll notice lots of town names and places you know of. So there's Genesee, Tully Limestone, Hamilton, right? These are all local areas. So there's the Marcellus formation. That's where it formed. And it's black on this slide because it's a black shale, just to point that out. There's another black shale way lower called the Utica Formation, similar to the Marcellus in a number of ways. One that you guys will be interested in, Lockport Dolomite. That's what they mine at the Dolomite Quarry. Yet another view, and this one gets to be really important. So this is a cross section. So this is like you took New York State, sliced it right here, moved the two halves of the state apart, and now we're looking from the side. So these are the different rock layers, and you can see they slope downward. Okay? This one's the Marcellus. So the rock layers are sloping downward. So it comes to the surface in Tully, and then it slopes downward as you go farther south. Here's another image that shows kind of the same thing. The dark green is where the Marcellus comes to the surface, and everything in the lighter green, that's where the Marcellus is found deep below ground. Okay. Now we have to play a little game, and I thought of this the last time I was speaking to a group about this. All right, so here's what I would need everybody to do. I want everybody to face that way and do this with your arms. I guess that group. So you want your arms facing towards the front and back of the room. And I think facing towards me so you can see what to do. Okay. Now, what I want you to do is now take your arms and tip them this way, right? So that your hand is kind of below the person in front of you. Okay. So this is what the rocks are doing in New York State. They're all dipping down towards the south, right? There's north, that's south. So every rock layer. So which layer wants to be Marcellus shale? Anybody? This will be Marcellus. Well, let's do one that goes all the way across the room. So this is Marcellus shale. So this would be, like over there would be Marcellus. Over here might be Leroy. So it comes right to the surface here. But notice, go towards the front of the room. If you get all the way down here, this would be like the Pennsylvania border. And by the time it gets to the Pennsylvania border, it's 6,000 feet below ground. Okay. So now you understand what the Marcellus shale looks like. And that's important to know. All right, let's talk a little bit about natural gas well installation and hydrofracking. What I want to talk about first is kind of old school natural gas well installation and hydrofracking. Okay, so in the past, what a driller would do would be go out to an area where they might be able to drill. So that's called over the river and through the woods, because it's never near a town. You're going to drill out where land is less expensive and where, you know, farmers will rent you some land or lease you some land. You drill through the soil and you drill through the aquifers. The aquifers are the layers that of either sediment or rock that contain water that we might want to use. You drill down through those aquifers. You drill through rock layers, right? And you drill down until you reach the layer that you think contains natural gas or oil, right? So you've got basically a hole that goes down through the rock. The next thing you do is you set pipe. You put a pipe that fits inside that hole, right? So the rock has a certain diameter hole. The pipe you put in is a smaller diameter, so it fits in. You've got a space in between the pipe and the rock. You fill that space with cement, and that sets the casing, holds it in place, and helps a little bit to prevent leaks. In the layer where you think there is oil or gas, they use tiny little explosions to make holes in the pipe so that the oil or gas can flow in. Right? So that's just drilling. Next, you would want a hydrofrac. For hydrofracking, after you perforate the pipe, you inject very high pressure water and proppants. So you inject high pressure water to crack the rock. Right? That's called fracturing or hydraulic fracturing. You inject with the water bits of sand, and those are to prop those cracks open, keep them open. You inject lubricants, and that's why it's sometimes called slick water fracking, because you want the water and sand to be able to get down to the formation as quickly as possible with the maximum amount of pressure with the least friction. So you would inject some lubricants. In the past, they would use diesel fuel as a lubricant. Now they use some other chemicals. Conditioners, things to keep everything mixed properly, and biocides. So what's a biocide? Any idea? Just looking at the word root. Well, bio and side, right? Kill things. It's a poison. It's kind of like what you might put in your pool because you want to kill algae and you want to kill, microbes or whatever else. And it turns out it's not actually very different from what you'd put in your pool. Okay, so that is kind of the story of hydrofracking. So what's new? And that wasn't a question. I'm not looking for an answer. So what's new? So what's new? Well, drilling down for gas in New York State is not new at all, right? That's over 150 years we've been doing that. One of the first places to drill in the world. Hydrofracking isn't new. They've been hydrofracking here, probably since the early 70s or so. Everybody recognizes that portion of the map, Western New York. Every red dot is a natural gas well. So that is definitely not new, right? So let's look at what's new. What's new is this combination of two things, directional drilling and hydrofracking. This shows what we were just talking about. You drill down, let's say this is the layer that you think contains natural gas. Tiny little explosions open up the rock, then you inject hydrofracking fluid, and that fracks the rock more, allowing the natural gas to move in. Remember, the shale is so tight, natural gas can't flow through. That's why they hydrofrack. So notice, if the Marcellus shale at its thickest is roughly 200 feet thick, once you do this process, you have 200 feet of natural gas containing shale that can yield gas to your well. Does that make sense? But with horizontal drilling, they drill down, and a couple of hundred feet above the Marcellus, called the kickoff point, they put in a different type of drill rig, a different type of drill bit that they can actually direct which direction it goes. So they direct it to turn and then drill horizontally through the Marcellus. So interesting thing is, now once you go in horizontally, you could go for 5,000 feet and do the same process, hydrofrack, and they do one hydrofracking bit at a time. So now instead of having a 200-foot thick, rather than having 200 feet of shale yielding natural gas, now you have 5,000 feet of shale yielding gas to that well. So that's why they do it. One more toy. So this is a roller bit. This is the type of drill bit that's used to drill down. And you'll see, when we pass this around, you'll see that it's kind of heavy. There are 3 metal rollers that spin. What happens is this is attached to a pipe, and the pipe is pushed down with great pressure, and it turns. And as it turns, these rollers crush the rock. At the same time, you can see this is hollow, right? At the same time that it's drilling down, they push drilling fluid down through the center of the pipe, right from the surface, that picks up all the little chips of rock and carries them to the surface. So that's how the drilling technology works. This idea, the roller bit, was invented by Howard Hughes's dad, and that's where the Hughes fortune came from. So directional drilling and hydrofracking. So putting those two things together, the directional drilling and the hydrofracking, that's what's new. So are there environmental benefits? Well, there are a couple environmental benefits. One is, remember the fossil fuels are interchangeable. We could use any one of them for anything. About half of our electricity in the US is generated by burning coal, right? And coal is just a horrible, nasty fuel. It destroys the environment when we're getting it out of the ground. It puts lots and lots of contaminants up into the air when we burn it. Puts in lots of negative materials, including things like mercury. So to any extent that we can replace coal burning with natural gas burning, I think is a good thing. So that's one. Let me go back to the middle of the room. So now let's say we want to drill down to the Marcellus for natural gas, right? And let's say this is hundreds and hundreds of acres instead of just the size of this room. Let's say we were using the old technology and you have hundreds and hundreds of acres. how would you drill down to get the natural gas? You could drill in a well here, and one there, and one there, and one there, one there, right? Because it doesn't affect much. But with horizontal drilling, what you could do is you could drill down here, right here, and then go out in that direction, all the way out to the corner of the room, right? From that same location, that same pad, you could then drill down this way, and this way, and this way, and this way, and this way. So you get significantly more natural gas, way fewer drilling locations. And the surface area, the drilling surface, that's where we really mess up the environment. So that's a positive. Are there any negatives to hydrofracking? Okay, well, okay, maybe that's overstating the case a little bit. Okay, sorry. I thought that was funny. Anyway, so what are some of the costs? There are real and perceived costs. And I think the costs can be either deterministic or probabilistic. And right now you're thinking, why did Mel invite a professor to talk to us? Okay, so what do I mean by that? Okay, deterministic, things that you could figure out beforehand. So, you know, we know when we put in when we hydrofrack, there's going to be so many hundreds of truck trips. We know when you do hydrofracking, you're going to use so many millions of gallons. You could figure this out as deterministic. You figure out how many wells, multiply it by that, deterministic. Probabilistic, problems that you don't know when or if they're going to occur. There's a probability that they will, but you don't know if it's going to happen, right? So those are the ones that we're afraid of. It turns out with risk communication, we know that people are much, much more fearful of things that are probabilistic and much less fearful of deterministic things. So, you know, if you drive your car for 100 miles, you know you're going to burn a certain amount of gas, you're going to put a certain amount of wear and tear on the car, blah, blah, blah. That's the deterministic. If you drive your car for 100 miles, you might get into an accident. That's the probabilistic, right? Doesn't mean we can't figure out the probabilistic. Definitely we can figure out the probabilistic. That's how your car insurance rates are set, right? You can figure it out. There are non-hydrogeologic costs and there are hydrogeologic costs. I know about the hydrogeologic costs. Okay, our second speaker will speak a lot more about the non-hydrogeologic costs. So water supply cost. The old type of hydrofracking well, where you just drill down and go through 200 feet, uses maybe a few 100,000 gallons of water. The new hydrofracking well is many millions of gallons per well. So just to give you a perspective on that, the Cobbs Hill Reservoir contains over 100 million gallons. Okay. So using the water is a problem. We're going to use up a lot of water. Any water used for hydrofracking, you're not going to use for anything else. This is a picture of the Susquehanna River basin, so you can have contamination in various locations. Water quality cost is what we're really worried about more, I think. So this picture kind of shows you know, a hydrofracked well going down, and you inject all those chemicals that we heard about into the subsurface here, and they could migrate back up to the surface. So what we want to keep in mind is you inject many millions of gallons of this hydrofracking fluid. When it goes into the subsurface, it comes back, around a third of it comes back up to the surface, but it comes back up to the surface through that same well that you injected it with, right? That's how it comes up to the surface. And when it comes back, it is contaminated, not only with the fluids that we added, but with some things that nature adds. After it's been down in the Marcellus shale and it comes back up, it is highly contaminated with salt. It's much, much saltier than the ocean. It is contaminated with some radioactive material, so it's definitely nasty stuff. People are worried about contaminating the aquifers. I don't think that's really the issue. The issue is surface water bodies. And what you hear people talking about very frequently is, well, you're hydrofracking down here. You're injecting and cracking the rock purposely in hydrofracking. Could we make a fracture that comes all the way up and hits the aquifer, right? That's a real concern. But I think if you look at it, it's not a concern that's going to happen. So I brought this yardstick to whack anybody who thinks that's going to happen. No, I brought this yardstick because I thought it would be kind of a good way to demonstrate something. So let's imagine we're at the ground surface and we're going to hydrofrack the Marcellus shale, which let's say at some location it's 3,000 feet down. Okay, so each foot represents 1,000 feet. All right, the Marcellus shale is maximum 200 feet thick. Right, and when they hydrofrack, they inject water down here and they're cracking the shale. Right, and they want to fracture all 200 feet of that Marcellus shale. So you're here at the ground surface, that's 3,000 feet down, subtract 200 feet, you're at 2,800 feet down, right? Let's say they make a mistake and put in fractures that are significantly longer than they expect, 10 times longer than they wanted to, right? So, and they drill through the middle of so if this area was the Marcellus shale, they drill through the middle, right? Have some fractures go up, some fractures go down. So they want the fractures to be about 100 feet long, right? Let's say they make a horrible mistake and they create fractures that are 10 times longer than that, which, by the way, the rigs don't have the pressure to do, but let's say they did, right? So now instead of being 28, instead of coming up 100 feet, let's say they come up 1,000 feet. You're still 2,000 feet below ground, okay? The aquifers we use, the layers of rock that are filled with water, are maybe 200 feet from the Earth's surface. Hardly anybody in New York State is pulling water deeper than 200 feet down. So you have from 200 feet down to 2,000 feet down, and that's if they put in fractures 10 times longer than they intend to. Okay. But what is the problem? The problem is we have lots and lots and lots of old wells that were put down into the Marcellus, right? Lots of old wells that were put down that are no longer in use, right? So if they inject the hydrofracking fluid and it's going through the Marcellus and hits one of those old wells, it could come right to the surface. The good news is New York State Department of Environmental Conservation has a real good idea of where those old wells are. So that helps out. Can it affect aquifers? Yes, it can. This map on the bottom, this shows the aquifers that are actually used for drinking water, right? So in Penfield, we don't use aquifers for drinking water. We get our water from Monroe County water. Another problem that you've heard about is earthquakes. Earthquakes caused by injection of hydrofracking fluid. I downloaded this yesterday. This is from U.S. Geological Survey. I don't know whether you could see it, but that was downloaded yesterday. It shows quakes over the last week, and there were 781 earthquakes in the U.S. over the last week. Oh my God. No. It just happens every week. There are earthquakes all the time. We just don't feel them, right? These are the kind of earthquakes we get in New York. The earthquakes we get in New York are very, very small, right? We are not going to get damaging earthquakes anywhere where the Marcellus shale occurs in New York State. You'll get earthquakes that are, you might feel them kind of the same way you might feel the blast on Tuesday morning from the mine. So can we talk? This is something, so here's the moral issue, okay? Tonight, 7 or 8 hours from now, it's going to be 22 degrees outside, okay? What temperature is going to be in your house? It's a miracle. How are you going to do that? You're going to burn natural gas. 90% of the homes in New York State burn natural gas. Okay? So to me, this is an environmental justice issue. Okay? I think this is an environmental justice issue. I don't think it's, environmental justice is something our second speaker knows a lot more about than I do, but the basic idea of environmental justice is you don't put all the nasty environmental sites where poor people live. Right? I think it's not a morally defensible decision to say, we want to gain the benefits of using natural gas, but drilling for natural gas, no, that should be someplace else, right? So let's drill for our fossil fuel on the coast of Nigeria, where shale oil completely destroys the environment, completely destroys the way of life of those people, but you know what? They can't afford lawyers. So I don't think it's defensible. NIMBY, you probably have heard the phrase NIMBY, not in my backyard. I think if you're going to say something is NIMBY, it really should be, this is a term I made up, NIABY, not in anybody's backyard, right? because that's not morally defensible. We also have a new term in the environmental field that I like a lot. I wish I made this one up, and that is banana. Build absolutely nothing anywhere near anything. Okay? There are people who are against wind turbines in Lake Ontario. That's ridiculous, right? It's absolutely ridiculous. So this is my last slide. And this is a picture from Tug Hill. And what this is showing is eventually we're going to get to that, right? Completely reusable energy. It's an uphill ride. There's some clouds on the horizon, but eventually we're going to get there. Thank you so much, and thanks for putting up with me.
All right, well, good evening. Thank you for coming. Thank you, Josh, for a really interesting presentation. And thank you, Penfield Green Initiative, for putting this together. Just a brief bit about myself. I tend to spend most of my time as far as doing research and teaching, or more of my research, I should say, on the solutions to environmental problems. I'm interested in alternative technologies. And in fact, I'm writing a book about this. And so this kind of diversion into fracking, into sort of the doom watch end of environmental studies and environmental thinking is not something I typically would dwell in. But this issue is so serious that I've found it necessary to step up and lend my expertise to the issue and educate more broadly than just my students at Geneseo, the best I can anyway. What I'm going to do tonight is start by summarizing the four main arguments offered in favor of expanding fracking into New York State and elsewhere in the United States. Let's see if I can get that to work. So there you see them. The first is shale gas will make us more energy independent. We hear this a lot from both parties. There's a lot of excitement about energy independence so that we don't have to depend on getting our fossil fuels from hostile areas of the world and all the negative things that brings about. I won't be dealing with that much except to say that this argument is considerably weakened by the industry's well-documented plans to ship a significant portion of the natural gas that it produces overseas. And that's not really surprising, and you're looking at one of the vessels that does that. That's not really too surprising. Gas is not, unlike oil, I should say, gas is not traded in a unified global market. So there are differences regionally in the world in terms of the gas prices, and they can differ substantially. And as the United States supply has increased largely due to the exploitation and the extraction of shale gas, prices and flooded the market, prices have consequently fallen in the United States. However, in Asian markets and in European markets, the supply is lower and therefore the price is higher, and therefore the incentive to ship the gas overseas. That, I think, puts a big dent in the argument that this is all about energy independence. The second of these arguments is the bridge fuel argument, and this is one that the Obama administration is particularly fond of. And that's basically that natural gas is a necessary bridge fuel to get us to an as yet unready green energy future. Again, I won't be dealing much with this except to point out that that this view ignores a couple of things. First is that the ample evidence that a more sustainable energy strategy is already viable. And I won't have time tonight to really go into this in any detail, but I'm just going to throw a few of the kind of typical elements of a more sustainable energy strategy that this is what I would see as being a a ready-to-go kind of strategy. And a number of prominent specialists and experts in energy issues, including Amory Lovins and Jacobson and DeLucci lately from Stanford, basically echo these sentiments. So again, I won't have a whole lot of time to go into that. That's a whole other lecture or 10. So that's the first, I think, the first problem with the bridge fuel argument. The second is the fact that heavy investment in shale gas would divert resources. It would divert resources that would go into research and development into a more sustainable energy future. It would also divert investment capital away from building that future. Historians of technology like to refer to complex technological systems that have a sort of momentum of their own. And when you build out an infrastructure, an energy infrastructure with all its various pieces, you make a kind of concrete commitment to a certain direction, and you don't reverse that very easily. I'll be focusing my comments on the other two arguments offered in support of fracking. The first of these is the environmental argument, and this is the claim that shale gas is a clean alternative to other fossil fuels, and the corollary to that, which is that fracking poses little risk to our health. And then the fourth argument is the economic argument, and that's simply that fracking will benefit the local economies in which it's practiced or adopted. Hopefully I'll have a little bit of time at least to talk about that. All right, so let's talk then about, or begin by looking at the environmental argument for fracking. And to grasp well, I should say, I usually do this presentation where I do pretty much all of what Josh did and then this stuff. So I've had to kind of condense and chop things up a little bit here, so excuse me if it seems a little disjointed. But what Josh didn't really talk about in focusing on the Marcellus is the Utica shale. And so you're looking at, in the yellow boundary is the Marcellus, and the large green splotch there is the Utica, which is much further in its extent. And I think this is particularly important for understanding, what are the implications of all this for Penfield and for Monroe County in general. The Marcellus shale stops south of Monroe County, as many of you know. But the Utica clearly does not. It extends all the way up to Quebec and down to Tennessee. The gas industry, well, let's just say the organic content and a suitability for drilling in the Utica is still being explored and evaluated, but preliminary signs suggest that it will be commercially productive. And in fact, the gas industry has started to drill it in Quebec, in a little bit in Pennsylvania, and especially in eastern Ohio. And the wells in eastern Ohio have been turned out to be pretty rich in oil and natural gas liquids. New York State is also a potential target as far as the Utica goes. Norwegian-based Norse Energy Group has applied to frack Utica Shale in Shenango County. Gasstem Incorporated has expressed interest in New York State Utica Shale and has in fact drilled a Utica well in 2009. They did in Otsego County. And there's a lot of, I think, a lot of hope that this will turn into something. And you can sort of see here, these are two executives from the two companies I just mentioned, and their view on just how promising the Utica shale actually is, and they see it as being essentially as good or better, or as promising or more promising even than the Marcellus, possibly. Will it be productive right here? It's hard to say. I would note that the Utica shale that's being drilled in eastern Ohio and that is productive is at a depth of about 2,000 feet. And the Utica shale under Monroe County is about 2,000 feet. Other than that, I don't know if it, how carbon rich it is. I can't really tell you, and I don't think that many geologists could tell you that at this point. Now, to be sure, I think the gas industry is going to target the more easily accessible gas reserves, especially in the Marcellus, first. But with that well underway, I think the Utica Formation is clearly becoming a serious target. Will it unfold here? It's anybody's guess, I think. All right, so that gives you a little bit of the sense of my take on the geography of this a little bit. So let's talk about the environmental and health impacts. Two main considerations with respect to the environmental impact. That is the environmental impact of burning natural gas as a fuel. Yes, it's a cleaner burning fuel. No doubt about that. As far as all the range of choices in fossil fuels, it is the cleanest burning fossil fuel. It's still a fossil fuel, unlike renewables. But any assessment of its cleanness really has to go beyond the combustion point and really deal with the life cycle process of extracting or developing shale gas. And that really gets you into extraction, processing, distribution, combustion, which is certainly there, and waste management. So when all those steps are included in the evaluation, then what sort of environmental impacts do you see? Well, I'll focus my comments on two of the most important of these, and with apologies to Josh for overlapping some of what he's talked about here. The first is pollution of water and air and the health consequences that result from exposure to that pollution. And then the second is a heavily industrialized landscape, which is make no mistake about this, a necessary byproduct for shale gas development. And this involves heavy truck traffic, well pads, access roads, pipelines, compressor stations, and the rest of it. So let's begin then with water pollution and water use. And again, a little bit of overlap here. Each fracking requires between 2 and 8 million gallons mixed with chemicals and proppants. The gas industry stresses, and that's what this is, that 99.5% of the fluid, the frac fluid, is water and sand, and then the 0.5% is chemicals, and so not to worry. But that means between 100,000 and 400,000 gallons of chemical additives are going in per well, and so this is what that looks like when you're on a well pad. The things that are circled are the chemicals. Moreover, each well can be fracked up to 10 times over during the course of the well's productive life. And this requires, as Josh was saying, massive water withdrawals, and it comes from the water comes from lakes, rivers, streams, wetlands, ponds, aquifers, and this poses a danger to aquatic ecosystems, to fish populations, to drinking water aquifers, and not such a big deal here in Penfield apparently, but where I am it is, in Rush. Unlike other uses, as Josh mentioned, the water used in fracking it's a consumptive use. That is, it's removed from the hydrological cycle. You're not using it again. It's too contaminated. Now, my figure is around half the water, or the fluid, I should say, stays in the ground, but you had a third that comes back up, so I think there's a range there, yeah. The remainder comes back up as flowback, or that's the sort of euphemistic term for wastewater. How will that wastewater be disposed of in New York State, you might wonder? Well, the DEC's environmental impact statement recommends allowing permits for a number of ways to get rid of it. Temporary open pit storage. Let's just look at what that might look like. That's a well pad in Dimock, Pennsylvania, and you can see the pits there, the reserve pits, and there's another with an impoundment. That's one way that you can get rid of it. You put it up onto the surface, put it in these pits, and then you would truck it. You'd pump it into trucks and truck it typically across the border into Ohio, where the geology is a little more favorable for this, and you inject it deep underneath the ground and cause a bunch of earthquakes, right? Which are not very big, as Josh says. That's the least of the worries, I think. But nevertheless, it is somewhat of a concern. So you have open pit storage, injection wells, municipal sewage treatment plants. You can run it through those, and then discharge it into rivers, sometimes right above the drinking water intakes for other municipalities. Not a good thing. And you have private in-state treatment facilities transporting water to other states. That's all being considered. And road spreading. This is also under consideration, has not been approved, but is still on the table, so to speak. And there's what that looks like. So you can spread this stuff, which is very salty, as Josh says, to melt ice in the winter. You can spread it on roads when it's dusty, if there's a construction project, such as building an access road for a gas well or whatever. You can conveniently spread your own wastewater all over the watershed. Now, what we need to know, what do we need to know about the chemicals that are used in extraction, gas extraction? Well, three main things. What they are, how dangerous they are, and then what are the potential pathways of exposure. So what are they? Figuring that out has actually been more difficult than you might imagine, as the chemical composition of the frac fluid products, of which there are literally thousands, is considered proprietary, a trade secret. So what we do know, however, and we know it through material safety data sheets from OSHA and from accident reports from EPA, we've been able to piece together the information, is that over 600 chemicals are used in gas extraction in every stage of the process, not all at once in any given frac fluid, but this is sort of the menu that you can pick from. And they are combined into various formulations to make up or to add to the frac fluids. These chemicals fall into several functional categories, and Josh talked a little bit about them, and they're right here. I don't really have time to go into them in any depth here, except to say that the slick water part, the word slick water that you always hear, as Josh said, is the lubricant part, and that's one of the more sort of famous pieces of this, but it's clearly far from the only functional category of chemicals. So that's what they are. How dangerous are these chemicals? It turns out that many of them are neurotoxins, carcinogens, and endocrine disruptors. And that's I like this little cartoon. It gives you a good flavor for the sort of discrimination between watersheds in our state. New York City and Syracuse, because they're unfiltered, are protected. Everywhere else, well, I call this the chopped liver argument. So there you have it. And in addition, as Josh says, in addition to the chemicals that are intentionally added to the frac fluids, what comes back up comes up with all sorts of other nasty stuff, hydrocarbons, heavy metals, naturally occurring radioactive materials, all that while it's underground, then comes back up. So that's how dangerous they are, roughly, and or in a nutshell. The third piece of this is what are the potential pathways of exposure. Two main pathways, two main categories of exposure, you might say: surface events and underground events. Surface events include the obvious things like spills, leaky waste pit liners, overflowing pits during heavy storms, like Hurricane Irene, for example. Then you have things like illegal discharges on the roads and in creeks, which does happen. And even without those kinds of discrete events, you have another issue, and that is that the VOCs evaporate from the reserve pits and and can condense then in the atmosphere and basically kind of rain down in an ecosystem. So you get exposure that way. Yeah, oh, sorry, volatile organic compounds. The underground events are more controversial. Three main possibilities here. You have failures in cementing around the well casing or failure of the well casing itself. The industry admits that this happens. This is, in fact, their preferred explanation when there are issues of contamination, because they can, adopt best practices to fix this all up. It's within their control. It's not something inherent about the process. It's just bad practice. The reality of this, and they say, though, this happens, but they say that it's rare that it happens. The reality, it turns out, is that 1 out of 20 wells fails immediately. And the older a well gets, the more likely it is to fail. And those are stats from Tony Ingraffia, an engineer at Cornell who's worked in the oil and gas industry for many decades. The second possibility here, fracture communication. Again, Josh talked about this. This is basically unexpected connection to abandoned wells, which then act as conduits and bring the water up to the aquifer layer. In 2009, the DEC, New York State Department of Environmental Conservation, documented over 4,100 abandoned wells in New York State. I'm not sure I agree that they know exactly where everything is, and I came across this other quote here on the left that I thought would be of interest. The DEC, this is from the DEC's Division of Mineral Resources. It came out in 2009, this study. DEC has at least partial records on 40,000 wells, but estimates that over 75,000 oil and gas wells have been drilled in the state since the 1820s. And as you can see, most of them well before the regulatory kind of measures to control how the casing and the cementing is done, and therefore, and are often left unplugged. And so those kinds of numbers suggest that they don't quite have as firm a grip on this problem as you might imagine. And the other thing I think is that I would mention here is that the longer the well is in place, the more chance you have of the steel and the cement deteriorating over time. So you have problems. Some of them don't have any casing at all, it turns out. So that's a big problem and a big concern. The third here, the third issue or possibility for underground events is the most controversial, and that's the chance for migration from the new fractures to existing ones. Josh actually was talking about single fractures that would go all the way to the surface. I'm not sure that that's really necessary, to tell you the truth. When you understand that what the fracture system layout or geography is in New York, or geology, I should say. I'm going to show you two maps now, okay? This is included in the DEC's environmental impact statement, and it's their mapping of the fracture systems in New York State. Okay, that's what they're basing their regulations on. This next map is from Robert Jacoby, who's a geologist at the University of Buffalo, who did a much more careful study of the fracture systems. And as you can see, there's quite a difference here. So the notion, how deep they go I mean, this is something that you might be able to answer better than me, certainly. But the geologists who I work with actually down at Geneseo are concerned about this. The possibility that you would frack and cause a fracture that connects up with some other fracture, some other fault or joint, which are the kinds of cracks that you see in a fracture system. Now, the science of all this is still incomplete on the potential for underground exposure pathways. What we do know, however, is that there are more than 1,000 documented cases of water contamination near fracking sites. And the latest evidence comes from an alarming EPA study that was done in Pavilion, Wyoming, which was heavily drilled for 2 decades. And the EPA sunk a couple of environmental test wells into the aquifer out there and pulled back samples that contained 50 times the safe level of benzene, which is a known carcinogen, among many other nasty things. But the non-disclosure agreements that people, basically, let's put it this way: if your well is contaminated by a drilling operator and you want to get compensated for it, you won't get a dime from them until you sign a non-disclosure agreement, and that ends up sealing the court documents. So the amount of information we have on this, and to actually connect the dots and to say, well, those instances where there are thousands of cases of contamination near wells, we can't say definitively that they're all caused by fracking, largely because there's this sort of what one EPA whistleblower, Wes Wilson, calls a conspiracy of silence, which I think is an apt phrase. And we'll talk more about Weston Wilson in a second. So that's water pollution. The other thing that's not mentioned very often, which I think is a shame in the dialogue we're having in the state, is air pollution. Natural gas may be the cleanest burning fossil fuel, but the latest science suggests that when the full life cycle of shale gas development is taken into consideration, this shale gas doesn't look all that good with respect to its greenhouse gas footprint. And so the study in question here, the main one is one that came out of Cornell University in 2011. This is a peer-reviewed study. It looked at the greenhouse gas footprint of the life cycle of shale gas, especially the CO2 emissions, but even more especially the fugitive methane. That is the methane emissions that come off of the wellhead and everywhere else downstream in the distribution system. That's in blue there is the sort of the main conclusion here. In a 20-year time frame, shale gas footprint is up to twice, the shale gas greenhouse gas footprint is up to twice that of coal for any use. A 100-year time frame, shale gas footprint similar to that of coal for non-electrical uses. Okay, and that we can get into this. I don't really have time, but in the question and answer, if you want to talk more about how to interpret that, it's a little bit tricky, but that's essentially the conclusions. And I think this really throws the whole notion of natural gas as a bridge fuel into question, especially when you're talking about the 20-year time frame, and you're talking about climate scientists who say we're approaching tipping points on within that range, where we could really kind of tip things into a very bad direction as far as climate change goes. So I think the 20-year time frame is quite relevant, as do the scientists who conducted this study. Another issue, another important problem here is ground level ozone. And basically the off-gassing of volatile organic compounds, VOCs, the off-gassing of hydrocarbons and also of fugitive methane ends up mixing with nitrogen oxides from the diesel exhaust of stationary equipment and the heavy truck traffic that's necessary to make all this happen. This produces very high levels of ground level ozone, even in rural areas. So you're looking here at Sublette County, Wyoming. You don't get much more rural than Sublette County, Wyoming. I actually had a sister-in-law who worked on a ranch out there, and I had the opportunity to visit her, and it is just like that as far as you can see. And they have had ozone levels in the last few years that have spiked higher than Houston and Los Angeles at times. Ground level ozone is associated, for those of you who don't know, with urban areas, urban industrial areas. So this is really quite surprising. So the health risks of this are substantial. The health risks of repeated ozone exposure include asthma, permanent lung damage, and I think it's worth keeping in mind that this can travel up to 200 miles from the point of where you're creating it. And it's also worth dwelling on the fact that the most vulnerable people to this are children, because they play outside a lot, and elders. Another environmental impact associated with fracking is traffic and noise. Basically, you see a dramatic increase in heavy truck traffic with drilling, with fracking. Each time you go down and out, requires an average of 1,000 round-trip truck trips, and this is over a span of maybe 2 to 5 years. A well with, say, 10 laterals, you're talking 20,000 one-way drive-bys, essentially. And your roads start to look like this. The noise is also quite extraordinary from the trucks, from stationary equipments, on the drill pads and the compressor stations. And I just have a couple of shots of just sort of, what this looks like. It takes a lot of pressure, as Josh was saying. We're talking 10 to 15,000 pounds per square inch to make this happen right. I'm not a scientist, so I need a way to make those numbers make sense to me. I'm an historian, so I teach, for example, about the civil rights movement, and I know about those fire hoses that were used on civil rights protesters in 1963 down in Birmingham. And those were, the water comes out of those at 100 pounds per square inch, and it is powerful enough to rip the bark off of trees, to break your ribs and knock you several feet in the air. So that's 100 pounds per square inch. We're talking about 10 to 15,000 pounds per square inch. And then you start to realize, what we're dealing with here, and why, for example, the well casings in the cement might not be as able to withstand that as you might imagine, especially if you do it 10 times over. So given all these serious environmental and health impacts, one would imagine that the federal government and the state government would be on the job protecting us. Unfortunately, that's largely not been the case. And that regulatory vacuum is a kind of a long and complex story that I won't have time to get into tonight, but I do want to kind of hit on the high points of that, at least to give you some sense of this if you're not familiar with it. In the mid-1990s, this begins in the mid-1990s really, with a private well contamination issue in Alabama where they were fracking methane coal beds. This led to a lawsuit against the EPA for not regulating it sufficiently in that state. And that, in turn, then prompted the EPA to initiate a nationwide study of fracking in methane coal beds and what risk that poses to drinking water. That study began in 2001 and then was completed in 2004. And EPA released its findings, concluding that fracking, first of all, quote, poses little or no threat to water sources, except diesel fuel. That was the one exception. If you use that in your frac fluid. And secondly, quote, it does not justify additional study, end quote. That, in turn, led this whistleblower who I mentioned before, Wes Wilson, a 36-year EPA regulator and environmental engineer, to seek federal whistleblower protection and criticize the EPA openly and take them to task for what he called a scientifically unsound study. For example, 5 of the 7 members on the review board had ties to the gas and oil industry. The gas and oil industry and their politicians that do their bidding now had been trying actually for years to have fracking exempted from the Safe Drinking Water Act, which was passed in 1974 and regulates industrial injection wells. And they now gleefully use the EPA's coal bed methane study to justify that exemption, which was inserted in the Bush administration's Energy Policy Act of 2005, which explicitly forbid the EPA from regulating fracking under the Safe Drinking Water Act. This is known as the Halliburton loophole for short. And this has to do with Dick Cheney, who was vice president and the head of the Energy Task Force that sort of secretly put pressure on this to happen. And fracking is also exempted from all sorts of other federal regulatory laws, which we won't have time to go into in to various degrees. So basically, the federal government left the regulation of fracking largely in the hands of state regulatory agencies, which are typically underfunded and understaffed, and have looser standards than the federal government and are fragmented. They don't communicate with each other state to state very well, so lots of information gets lost that way. The multitude of serious flaws and omissions in New York State's environmental impact statement are beyond the scope of what I can talk about here tonight, but they are an object lesson, I think, in the hazards of leaving everything to the states. And one prominent example here will suffice, and that is the health impact. Despite ample evidence that fracking poses significant health risks, the DEC failed to undertake a comprehensive public health assessment, and this has prompted the Medical Society of the State of New York, for example, to call for a moratorium. And as Heinz Award-winning biologist Sandra Steingraber recently pointed out, New York is on the verge of launching, quote, an uncontrolled human experiment using all of us as study subjects as a result of not doing a comprehensive public health analysis. Now, despite all that, New York State's de facto moratorium is about to end, and as soon as the DEC basically finalizes the environmental impact statement and its proposed regulations, which could happen within a few months. In the meantime, Wes Wilson's complaints to the EPA led the EPA to initiate a nationwide study in 2009. This is the biggest study on the possible effects of fracking on drinking water and water quality. Preliminary results are due out this year. Full results are due out in 2014. Yet the Cuomo administration wants to greenlight fracking before that study is complete. And Joe Martens, who's the commissioner of the DEC, says that we won't likely learn anything new from the EPA study. And Cuomo himself insists that he'll base his fracking policy on, quote, on science, not emotion. How that is so, I just can't imagine if you're not willing to wait for the biggest study nationally. So that's where we stand now with respect to regulation, and the regulatory vacuum at the state and federal level has basically left things in the hands of municipalities to protect themselves. And as of March 21st, 142 municipalities, actually this is including 48 which are in New York City and Syracuse, are protected. About just under 100 have actually passed measures, either a moratorium or an outright ban on fracking and its associated activities. Just so you know, fracking does occur in cities. This is in Fort Worth. It looks like we'll have to leave the economic piece of this to the question and answer period. I do want to say, though, that this is one of the biggest unexamined assumptions that I think is misinforming the whole debate in New York State and elsewhere, is that with whatever the environmental impacts and health impacts might be of fracking, it's going to bring necessarily economic development and good things in that way. And I think a closer look at that really reveals that that's a problematic statement. And that has to do with a range of problems, including the itinerancy, the out-of-state workers, the temporariness, the boom and bust cycle of extraction-based economies. And we can talk about that in the question and answer, as I said. I think I'll probably just have to leave it there and not go over here.
if you begin to fracture a solid piece of rock that's under the earth, aren't those little particles going to shift at some point in time? And is that going to disturb our activities on the earth? I know they thought that they dug coal mines in the 1800s and they shored them up with huge timbers, and I'm sure they thought those timbers would last forever, and they didn't. They're decaying at this point, and the ground is sinking. So I'm just wondering if there's a possibility of things shifting underground.
That's a good question, and you know, Yogi Berra said it's hard to make predictions, especially about the future. You know, when you hydrofrack, you're not creating any empty or open space in the subsurface, right? The fractures are millimeter size. Certainly when you do any kind of mining where you're extracting material, for instance, like the salt mine had the roof collapse, that's a possibility. But I don't think that's an issue with this. It's much more an issue when you're extracting a lot of water where the subsurface can sink. So I don't think that's one of the issues that they're concerned about.
Could you just speak a little more about the initiative that some of the municipalities have taken? We're getting mail about it, and I'm kind of interested to find out, is the state going to start trying to limit them, and how much power will they have?
Yeah, no, that's a good question. I think the Cuomo administration's position has been to let it be resolved in the courts. And there were 2 court challenges to municipalities that had passed bans on fracking early on. One of them was in Dryden, which is near Ithaca, and the other one is Middlefield, near Cooperstown. And those court cases were just decided a few weeks ago in favor of the municipalities that wanted to protect themselves. So it looks like, at least at the Supreme Court, state Supreme Court level, which is the lower court in New York State, the appellate court is the highest court in the state, that if it, at that level at least, the moratoriums, the home rule protection has held. If they appeal, they could appeal it. We're still waiting, I think, momentarily to see if Anschutz is going to appeal the one in Dryden at least, that we'll see how it resolves itself in that way. But I think my understanding is that there's substantial legal basis and constitutional basis for home rule protection. The key is, though, to get in to do it now before they start issuing permits. You have to do it then, because otherwise it becomes vested interest, and then they can sue the town for real money. Prior to that, they can't. This is one thing that David Slotchie, who is a real legal expert on these issues, emphasizes again and again, and that is that in the Dryden case, Anschutz had $5 million invested in leases, they claimed, and yet they did not sue for that. And the reason is because they can't, right? They couldn't. So, but once the permits start to be issued, the legal ground shifts. And so it's very important to get at least a moratorium. A ban is harder to get, but that's why everyone's going for a moratorium. They're pretty quick. It gives you like a window, and then you can work out how to jigger your zoning codes and your master plan and so forth.
Could you talk a little bit about the economic fallacies or the economic arguments and what you were alluding to?
Yeah, let's see where to begin. Let me just take a glance at my notes.
Let me jump in.
Sure, go for it.
Jordon and I think, are going to disagree on this, and I think we disagree on most things about the Marcellus, but let me jump in. I've got a student at RIT, deaf student, has 2 cochlear implants. They're quite expensive. He's from Ohio. He's from a farming family. His tuition and 4 of his cousins' tuitions being paid for by leasing from natural gas. I currently have 1 student employed as a health and safety, a graduate of our program, employed as a health and safety specialist in Marcellus shale drilling. We have a job offer into our department ready for somebody to take in May, working for a drill service company doing health and safety at drilling, and those are paying $55,000 a year for a college graduate right out of school. So if that's not an economic impact, I really don't know what is. Also, natural gas drilling, hydrofracking is going to be so significant economically, not just for us. It looks like China has so much shale gas that once they start doing the technology of hydrofracking for shale, it's going to have geopolitical consequences. They have so much shale gas, it's literally going to decrease their demand for crude oil from the Middle East, which is pretty important for us to know.
I guess, this sort of anecdotal evidence that Josh was just talking about of students whose families make money from the leases is valid. People do make money off of this. The question is, how long do they make money off of it, and at what expense to everyone else? This is what economists refer to as externalizing costs, I believe, right? So you can make a fair amount of money if you externalize your business costs, for example, what you're going to do with your wastes and so forth, put them into the commons, the air, the water, and then you don't have to pay for that. So everyone else does eventually, and society as a whole does. So I think that's problematic. But I think even, on its own terms, to look at it sort of more narrowly than through that broad kind of lens, the gas exploitation, shale gas development occurs in two stages, really. There's the drilling and construction phase, and then there's the operation and maintenance phase. And the drilling and construction phase is pretty short-lived. It can be 2 to 5 years, typically, maybe a little longer, depending on who you talk to. And that is labor-intensive. There's no doubt about it. On the other hand, the jobs tend to go to out-of-state roughnecks who come in from Oklahoma or Texas who have this particular set of specialized skills, and they go from well to well. So in Pennsylvania, I have if I can go to a slide with some statistics on it for you to show you. 70% of gas workers in Pennsylvania are out-of-staters, okay? And as far as the two phases go, the short-lived drilling phase accounts for 98% of the labor. So in terms of job creation, it's not a real muscular kind of job creating strategy. And in fact, those of you who read Paul Krugman's column the other day in New York Times know about this. He said that we've had a phenomenal increase in gas and oil drilling and extraction by a 50% increase since 2005 in this country, and yet it's yielded about 70,000 jobs, which is 1/20th of 1% of total American employment. That's a 50% increase. So there's a lot of hype out there and about job creation and economic stimulation. Most of it comes from industry-funded studies or from Penn State University, which is doing the bidding of industry. And the DEC kind of eats this up hook, line, and sinker without really questioning it too carefully. There's been a lot of pushback on it from activists and others in academia, academic economists who think that this is a completely bogus economic analysis. And that doesn't even get to what I would call, on the local level, the de facto unfunded mandate, all the things that you as a municipality are going to have to deal with. Even if you don't accept drilling here, you're going to get the secondary impact of this if it's happening regionally. The truck traffic, the damage to your roads, the added costs for first responders, the added costs for hospitals, social services. In Pennsylvania, the housing costs are so high as a result of all these people flooding in with these sort of short-term high incomes that it's driven people out of their homes. Renters, low-income renters, who can't afford to pay triple their rent when their lease expires, they get put out on the street. There's now a homeless problem in northeastern Pennsylvania where there wasn't one before. So this is, again, externalization of costs, and the gas industry does not like to talk about those externalized costs at all. They like to talk about the jobs that they create, and they have a very narrow sort of view of how to add those up
First, a little anecdote and then a question. The anecdote is I have a friend who grew up in northeastern Pennsylvania in Scranton area, where there was all kinds of regulations and agreements between government, industry, around where they would mine. And he recalls playing in the basement of a friend's house where they could hear miners talking on the other side of the wall. He also grew up in the environment where a fire burned for many years, somewhere over 20 years. Given what you've said about who's doing the bidding of industry and the way our political system is being run, both locally, more nationally, and certainly in the state, where corporate funding of politicians, and as you indicated, what's excluded already, can we trust industry at all, given the promises that are being made? What do you both say about that?
Why do you go first this time?
Well, I think you probably know what my answer is on that. And that's not to say that, everybody in the gas industry is evil or something like that. I don't take that point of view at all. But the evidence strongly suggests that they throw a lot of money at their public relations campaign. They flood the airwaves with it. And a lot of it, in my view, after having sort of picked it apart for, quite a while now, comes back, it seems to me to just not hold up. So I don't trust them for that reason. And it's not because I started, from the get-go not trusting them. There were a lot of environmentalists who actually thought this was going to be a good idea initially.
That would be me.
Yeah.
So to answer your question in another way, when New York State finally passes its regulations on hydrofracking in New York State, they'll be by far the strictest regulations of any state in the nation. Okay, that's one. There will be no pits containing return water in New York State, no discharges to wastewater treatment plants. None of that's going to happen. It's all going to be treated on site with mobile treatment plants. Then they reuse the water. So, there are a lot of problems in Pennsylvania because in Pennsylvania, at first, they allowed the hydrofrackers to do what they wanted. And when you let drillers do what they want, they will. Right? Pennsylvania's regulations now are significantly better, and New York State's are going to be the best in the nation. So I think something that's real interesting to look at is, let's say Ford has a new car on the market, and they say this new car is extremely safe, safer than anything in its class. And somebody asks, can you guarantee that this car will never be in an accident? Well, of course you can't. It doesn't have to be that guarantee. If it's safer than everything else, that's pretty darn good. And I don't think anyone would claim that there won't be any problems with hydrofracking, but it's significantly cleaner than all the other fossil fuels. The study that Jordon mentioned about having a higher footprint than coal, that's an extraordinarily controversial study. Most geologists do not agree with that. And there was a group at Cornell that claimed that the assumptions for that study were totally flawed.
Well,
so it's not settled.
They responded. Hovarth et al., who were responsible for the original study, responded to that quite convincingly.
Yeah, it's not settled.
Yeah, that's always the gas industry's point of view. It's sort of, you introduce doubt whenever there's science that's brought into play. You can't definitively nail it in almost any kind of environmental science, and so basically you just introduce doubt into it, and then you muddy the waters and you move on.
How much natural gas could be extracted per frac, and how much money could that be worth if all of the fracking goes without a snag? And additionally, how much is natural gas can be extracted relative to other fracking or relative to other drilling techniques other than fracking?
That's a good question.
I'm going to let you.
I don't know the answer on a per frac basis or even a per well basis. I don't have that info. That's a very good question. In terms of opening up shale to hydrofracking, the guess is that the Marcellus formation contains enough natural gas to meet all U.S. energy needs for about 15 years, which is extraordinary. Then you have the Utica Shale, which of course is below. I see there's some people with the no fracking buttons. I want a button that says Utica first. Okay, it's way, way deeper. It's thousands of feet deeper. It's significantly safer. That's the button I want. So per well, I don't know, but it's so much natural gas that it's going to have huge geopolitical consequences.
I just want to respond to something that Josh said before in the last round of questions, and that was that New York State's environmental impact statement and regulations will be the strongest in the country. First of all, I think that's not the case. I mean, it's certainly going to be stronger than Pennsylvania, but they set the bar so low that it doesn't even pass the laugh test. But the other part of this is it tends, the way that Josh has framed it, tends to focus on the issue of water contamination. He's an hydrologist, so that might be why. But that, I think, to take that as the proxy for the whole entire issue of safety, environmental safety and health safety is a mistake. Even if not one drop of water was contaminated or one watershed was ruined or one aquifer was ruined, all that truck traffic in the Finger Lakes region would be entirely out of place. You're talking about an industrialized landscape, essentially a landscape scale factory without a roof. And the way that the DEC approaches its environmental impact analysis is to look at each single well, a well by well basis, not the cumulative impact, not the regional industrialization. That has a huge impact on displacing employment in existing industries, like tourism, for example, incompatible with that kind of truck traffic, incompatible with an industrialized landscape. Organic agriculture, we're third in the nation in terms of the number of organic, certified organic operations we have here, 803, I believe, utterly incompatible with this. And even conventionally produced food, the food system is in jeopardy of being contaminated, and just by virtue of soil contamination, bioaccumulation in plant and animal tissues, and then we eat those tissues. So I just, the notion that everything boils down to the issue of water is an industry point. It's a talking point. And you need to be aware of that when you hear it.
The last shot. I want to address a statement that Josh made and ask him to give some details. I've been studying Pennsylvania's Act 13 in detail and following news reports about it. And your statement that the regulation of the industry in Pennsylvania has recently been improved doesn't correspond with what I've been reading about this act at all. The act has obliterated home rule so that towns can't have any decision about where and in what extent fracking occurs within their borders. It has placed a gag rule on physicians so that in order to find out if their patient is, the question is, how can you say that?
Okay, good question. Well, let's see. I was talking about Pennsylvania's environmental regulations, the regulation of drilling within Pennsylvania, right? So the regulations in terms of what they can do with the wastewater and how much pollution is let out into the environment is significantly stronger than it had been in the past. In the past, they were allowed to take wastewater that came back from the well and store it in ponds on the surface until at some later date they transported it off-site. That's not happening anymore. Companies in Pennsylvania, what they're doing now is the return water gets treated, and then the treated water gets reused on another fracking well. So I was talking about the regulations of the environment.
I want to respond to one thing, if I may, in Josh's talk, and that was at the end, that had to do with environmental justice. I find this an interesting argument. As someone who studies the environmental justice movement and its history, it just does not sit well with me. Largely because, some of the main environmental justice activists in the country are against fracking. Lois Gibbs, for example, who was the lead activist at Love Canal, and who then started a national organization that was eventually, its name now is Center for Environment, Health, and Justice, to work with communities around the nation on environmental justice and health issues, is adamantly against fracking, as are a number of mountaintop removal environmental justice groups in Appalachia. So I think before you sort of swallow the notion that, that it's wrong of us to refuse it on the grounds of environmental justice, you need to carefully consider this. And I think one of the issues in environmental justice movement historically is this concern that even if you can muster the ability to fight off a waste incinerator in your particular community, it might go to some other more vulnerable community. And so what that has led environmental justice activists to do is actually become much more interested in sustainable technologies, non-polluting technologies, and to actually bring that into the way that they think about things. And so it is a NIABE, it's a kind of situation from their perspective. It's not necessarily just a NIMBY position. They're very concerned about being NIMBYs. And I think by and large, they've avoided that. And I don't think that you should feel any kind of sort of white man's guilt for not wanting your water and your air and your health trashed.
Well, that's a lot to process and to absorb. I want to thank both Josh and Jordon for their wonderful presentations. And that was exactly what PGI, the Penfield Green Initiative, was hoping for, a robust presentation from various perspectives, and we think it was excellent. And thank you all for not only attending, but your questions and thoughtful questions they were to provide each of us with even more insight into this issue, which is very near and dear to many of our hearts. I do want to, again, thank PCTV for the opportunity for taping this, and so that all residents in Penfield would be able to have the opportunity to learn more about this in the luxury of their homes. And it was a lot for me to absorb tonight, so I'm sure I will review it and try to learn more about it by seeing this program again on PCTV. Again, thank you to the town and our supervisor, Tony LaFountain, for allowing us to use the auditorium here. And thank you to Kirk for being our moderator, and certainly to our two speakers, Josh and Jordon, if we could give them another round of applause. I do know there's, if either Phyllis or Marty want to get up to this mic over here. While she's doing that, I want to remind you that Penfield Green Initiative, as we said, our brochures are on the table. And we got to give credit to one of our members, Deb Murator, who does our newsletter every month. So we wouldn't be, if you want to sign up for the email list, we wouldn't be inundating you with emails. It's just to get our monthly newsletter. But she does a wonderful job informing us of that. We do have a Facebook now, and we can be contacted at our email address, which is penfieldgreen@gmail.com. So I think that's it for us. There's another group in town that wanted to say a couple words about their organization. It's newly formed Penfield Citizens Concerned About Fracking. So in a minute or two, if you could just kind of explain, and I know they have information on the table as well.
I'll be very quick because it's been a long evening with a lot of information. But we have just recently developed or brought together the Penfield Citizens Concerned About Hydro-Fracking. You will see on the table pink sign-up sheets. Please, if you are interested in learning what is happening in Penfield and you want to follow the newest developments and learn when the Penfield Town Board is meeting on these issues, give us your name and your email address or some other way to reach you. You should know that we also have a Facebook site, and that's a very quick and valuable way to find out what is happening. Penfield citizens concerned about hydrofracking.
And I just want to say, I'm Marty Korn. Thank you all for coming tonight, and thank you, Penfield Green Initiative, for arranging and orchestrating this program. Very useful.
Thank you again. And enjoy. I think the speakers will be around for a few minutes if you have other questions for them, and we will be around as well. Thank you all for coming, and we hope you enjoy and will be attending any of our future programs. We tend to have about 2 a year, one in the spring and one in the fall. So thanks again.